Okay, so we're going to integrate sine cubed times cosine dx. So I want to find the indefinite integral of this. So first thing I'm going to do is I'm going to rewrite this in terms of a u. So I need a u substitution. So what I'm going to do is I'm going to let u equal sine of x. So if u equals sine of x, that's kind of like my inside function. Sine cubed of x looks like this. So it definitely looks like I've got a u function and here an inside function, and then I see the differential of that u sitting right there. So it's a good choice for u. So if sine of x is u, then sine cubed is u cubed. And du, the differential, I take the derivative of sine x, I get cosine x dx. Lo and behold, I see a cosine x dx here, so I'm going to replace that with du. Now I just need to integrate. So I'm going to integrate u cubed. So I'm going to add 1 to the exponent and then divide by it. So I have u to the 4th over 4 plus c. Only thing left to do is to take the integral and get it back into terms of x. Since I started in terms of x, replace u with sine x. So I have u sine to the 4th x over 4 plus c. All right, the next one here, a little bit more involved, but it's still a u substitution. I want to integrate, find the definite or indefinite integral, the antiderivative of x squared times the tangent of x cubed plus 1 all squared for the tangent. So in reality, what this looks like, I know this is kind of weird, but it's tangent of x cubed plus 1 all squared. That's the same thing, that's what's written right there. Okay, just a different way to write it. So my inside function here, you might be tempted to say, hey, look, the inside function is the tangent of x cubed plus 1. And you could do that, but you're going to get a really complicated du. So let's try to go even more inside than that. Okay, so let's pick u equal to x cubed plus 1. Why do I pick that? Because I see an x squared and a delta x here. So I'm thinking, okay, I know the derivative of x cubed is a multiple of x squared. So that's kind of my idea there. So if this inside here is equal to u, then I can rewrite tangent squared of u in here. Okay. Now all I need to do is find the differential. So I'm going to take the derivative of u and I get 3x squared dx. And once again, I see 3x squared dx, but out here I see x squared dx. So two options. You either solve this bad boy for dx and plug in for dx here, or you make this look like that. To do that, I need to divide both sides by 3. If I divide both sides by 3, the 3's cancel there, and so I'll get 1/3 du is equal to dx times x squared. Okay, so I'm going to put 1/3 du in right here to replace these parts right there. Okay, now I need to integrate. In order to integrate this, though, I don't know what the antiderivative is of tangent squared, but what I do know is there is a trigonometric identity that I learned from pre-cal, Pythagorean identity, that links something that I do know. So to do this, I take sine squared plus cosine squared equals 1. And to derive the identity that involves tangent, I'm going to divide everything through by cosine squared. Dividing sine by cosine gets me tangent squared. And then cosine divided by cosine is 1. And then 1 over cosine is secant. So that's secant squared. Okay? So I have this identity here. I've got tangent squared here. So to solve for tangent squared, I'm going to subtract 1 from both sides. And so I can replace tangent squared with secant squared minus 1, which is useful to us because if you look at your integral rules, you know, well, sure enough, I don't have it on mine, but this integral of secant squared is tangent. So that's one of the integral rules. So that's why that was important there. So I've got the 1/3 constant out front. The integral of secant squared is tangent u. And the integral of negative u, or negative 1 is negative u. And then I have my plus c. Okay, so I'm going to simplify. I can't leave it in terms of u, so I got to get rid of the u here. U is equal to x cubed plus 1, so I'm going to plug in an x cubed plus 1 everywhere I see a u. Now, my final answer here is going to be 1/3 tangent of x cubed plus 1. But then I have the negative 1/3 distributes to the x cubed. But then the negative 1 distributes to that 1 here. But what happens? This gets me a negative 1/3 plus c. But remember, c is just a constant. And negative 1/3 is a constant. So it's like that constant absorbs the constant. So we don't need to have that negative 1/3 there. And we just write c plus c there. Okay, there's no need to have plus a negative 1/3 and plus c because that's just a constant. All right, hopefully that was helpful in showing you how to do U substitutions with trigonometric integrals.